Okay, question 6, we should be thinking this is definitely a integration question because we're looking at a shaded area, but the first thing they're trying to get us to do is get this x coordinate to give us the limits. Now, when you look at this, you might think, fair play, I've got 0, I've got 9, so 4.5 would be the midpoint, and that would be okay if you had a parabola, like a quadratic power 2. That would be bang in the middle there, but we don't, so this, although it looks in the middle, it's just slightly off. So the only way we can solve that is to say, well, I know that at the stationary point, the gradient dy by dx is equal to 0, n is equal to 0. So first thing I'll do is differentiate. So it'll give me 6, take away, so I'm multiplying them together, so 6 divided by 2 will give me 3, and I'm taking 1 away from the power, so that'll be the half, yeah? And I'll say then for stationary points, dy by dx is equal to 0, so I know that 0 is equal to 6, take away 3. I'm going to put that as a root just now because I think that'll make it easier to solve. So let's put that to the other side then. 6 is equal to 3 root x if I add 3 root x to both sides. Divide both sides by 3, so 2 is equal to root x. So 4 is equal to x. Okay. Square root of 4 would give me 2. Right. So that makes sense then, doesn't it? 4. If you were to say the half number, it'd be 4.5. So obviously it's not quite it's not a parabola, but quadratic. So yeah, and you know what? Actually, that's just annoying me a little bit. I'm going to just have to finish it like that. Sorry. So let's just check the marking scheme. Let's see where we're getting our marks from. So you're getting a mark for differentiating one of the terms. Your second point for differentiating another term and putting it equal to 0. So kind of to here effectively, and then your final mark for solving. So I hope, I think that's an easy question, but if you were struggling to understand what it meant, when you see a stationary point, you should think differentiation. So there's a little buzzword, stationary point, you should think stationary point, and for stationary points, the gradient is 0. The gradient, the rate of change, whatever you want to call it. And now we're going to calculate the shaded area. Okay, so for the shaded area, I'm going to have to integrate the curve 6x take away 2x to the 3 over 2. In fact, I'm going to put that in a different colour. So 6x take away 2x to the 3 over 2. So that's our function that I'm integrating. I'm going to integrate it between the limits, which is 9 and 4. And sorry, I'm going to put these in the green. So anything green is like a setup, okay? Yeah, absolutely. And I'm going to integrate with respect to x. Okay? So that's my limit there and there. And I need to make sure I say I'm with respect to x. Now at this point, it's worth just reminding yourself how to integrate. So I would do a little bit on the side, maybe over here, just say y is equal to x cubed. So if I differentiate it, I get 3x squared. So if I want to integrate it, how do I get back to that point? Well, I add 1 and divide by the new power. Okay, so I'm just adding 1 and divide by the new power. Just something to remind you, okay? So if I, by this point, sorry, I'll keep this in green. So if I integrate with my limits, I'm going to have the box like this. So again, just get that ready. Okay, so now we're going to add 1 and divide. So it'll be x squared, and then 6, I'll do the whole thing. I'll just say 6 divided by 2, yeah? If I add 1 to my power, that'll be 5 halves, 2, and I'm going to divide by the new power of 5 halves. And then we're all about, making it a bit nicer. So let's do one more line where we just tidy that up. So this is part B, isn't it? So 6 divided by 2, that's quite easy. 3x squared, even I can do that. And then over here, I would do a little side sum. I'd say I've got 2 divided by 5 over 2. And I'm going to do my old KFC, keep flip change. 2 multiplied by 2 over 5. So that's 4 over 5. So take away 4 over 5. X, at this point I'm going to write it as the square root of x to the 5, just because that'll be handier for when I'm substituting it. Okay. So far we're doing well. We've got our mark for the setup, mark in here. We've got a mark for the actual integration, so that's really good. And now we would get a mark for the substitution. So I'm going to put that I've got 3. I'll just leave a big space. In fact, I suppose I've got a calculator, so I don't really need to worry about that. So maybe actually, you know what, maybe I'll just leave it as x to the 5 over 2, because you can do that in your calculator. So this one's where I substitute in 9, and I'm taking away the same again, but I'm substituting 4. So much easier doing it with a calculator, isn't it, than without? You know, I'm just thinking, oh, I'll just plug all this in. So at that point, you've still got another mark just for writing down what you're going to do. Okay, so we'll just take our time with this on our calculator. And you should have got that in your calculator. So I did both brackets, separately. I just I still kept it individual. Let me just write that on the next line to make it look a bit neater, actually. Yeah, and also you can reuse your calculator sum. So if you write it in your calculator for the first bracket, you can then do the same again. If I'll move that over a wee bit, do the exact same sum again and just change out your variable. So it's actually much easier than doing it by hand. Doing this by hand is a bit annoying, and I always say just to miss this out by hand and come back to it, because it can sometimes be a fair bit of working for 1 mark. But for this, it's very nice. Just make sure you put in plenty of brackets. I put this in a bracket and I put this in a bracket just to be safe. If you do 9 to the power of 5 over 2 times 4 over 5, bod mass will work out okay. But I would just make sure that's in a little bracket, just out of paranoia, really. But yeah, just be careful with your bod mass, and I would do this separate from this. So my calculator is not a mass, a huge big equation, and just go back and just change the 9 for the 4, and that's it. So you could put it as a fraction. The marking scheme actually does have it as a decimal as well, so they weren't penalising if you put it in the decimal form and said that as well. It's fine. I would usually leave these as a fraction. So yeah. Not bad, is it? Not bad. So that's question 6 done. Question 6 done.